Okay, so now let's actually look at this code that we created and verify that it actually works the way that we expect it should. So let's run this. Once again, we're going to drop into the Python debugger. So we do a listing of our code, go ahead and step through this, go ahead and create an instance of that class. You can see that we have an instance of CiscoIOSXE. Now when we call the open method, that's actually going to go to our parent class. That's going to establish that SSH connection to the device. Now this setup method is actually in the CiscoIOSXE class, and there's actually a breakpoint in there, so we can go ahead and hit continue. We'll hit that breakpoint, and you can see where we're executing from. You can see that we're actually executing from that line in the CiscoIOSXE class. You can see that we're going to use that self.send, which is in its parent class. So here we're actually using a method that's in the network device class to send this. So one other big benefit of using class inheritance is it lets me reuse code. I don't have to duplicate the same code in a whole bunch of places, which very quickly can start to become a maintenance nightmare. So now you can see we're sending the terminal width, we're sending the terminal length. We go ahead and just read that back, so we've sort of cleared the buffer. We could look at what that output is. You can see that we sent those two commands down the channel. Okay, and we could step through. Now you can see we get down here, we're just going to send an enter. Now let's go ahead and try to send our show version. So, okay, so let's go ahead and execute that. And now let's do router1.send show version. Remember our enter this time. Whoops. Okay. Okay, send that down the channel. We'll say out equals router1.receive, see what we get back, and look at the output. And now you can see we have the entire output, i.e. our output paging worked correctly. Okay, so now let's go ahead and look at an example where we expand on this, except we have a Juniper device. So let's look at what this might look like with a Juniper device. Okay, so here we have code that has both CiscoIOSXE and JuniperJunos. And notice they're sharing all the open code, the init code, the receive code, and the send code. And the only thing that's unique in each class is the setup. So setup is unique, i.e. we have different commands to set the screen width, to set the screen length, i.e. to turn off paging. We can initialize both those. Now you can see the glue code that I have for both of those. Let's go ahead and execute that to make sure that that works correctly. Okay, so go ahead and step through this. I'm going to go ahead and put a breakpoint at 72. Okay, so here's our connection to the CiscoIOSXE device. So there you can actually see that it printed out what it did on the screen. Now if we did, well actually let's do Juniper because I've already shown you that the CiscoIOSXE works correctly. Let's do the Juniper one. So we're establishing the SSH connection. We've set it up. You can see the echo of the commands. So now let's do con2.send and let's do show configuration. I wanted to do something that would probably require output paging on Juniper. So we can start to do print output. Oh, once again, I forgot to send my enter. Okay. Let's go ahead and send the enter down the channel. Oh, I did two things wrong there. I forgot to send the enter, and I also actually didn't receive. I tried to just print out what's returned from the send method instead of doing the receive call. Okay, so now let's do out equals con2.receive. So we'll receive whatever we get back from that connection, and then let's look at print out. And you can see that I've got the output of that command. You can see the paging looks like it worked correctly. So the key thing we were showing here is just exactly what I was talking about earlier, which is this command hierarchy, or this method hierarchy. So we basically are going to use this method resolution order to resolve the methods and the attributes for a given class. So if you have a device that's an instance of the JuniperJunos class, it's going to first look inside that class to find the method. It's then going to traverse the hierarchy of its parent classes. And if we look at that in a diagram perspective, you can see what I have here. So here's looking at the CiscoIOSXE. Here's my child class name. You can see that it inherits from the network device class. Now in this example, I've actually written in an init method. So say there was something that I wanted to save, that I wanted to do that was special to CiscoIOSXE. So here I've said _init. I specify ourself. Now star args and star keyword args, those are a special way to allow in any number of arguments. So this would be a list of all positional arguments. This would be a dictionary of all keyword arguments. So these are pretty well-known patterns in Python. So once again, you can look these up and probably work it out pretty quickly. But this is just allowing any number of positional arguments and any number of keyword arguments. Now, what the heck is going on with this super call? So in some situations, not only do you want to have the child class have its own version of a method, but you actually want to call the parent class as well. So here, we're defining init in the child class, and then with super, we're actually going to call this method on the parent class. And there's actually a way it goes and works through the hierarchy to invoke this. So it basically will use the MRO to try to find where this init method exists in its parent class hierarchy. And then all I'm doing here with the star args and star keyword args is basically saying whatever positional and keyword arguments I get here, I'm just going to invoke the parent class with those exact same positional and keyword arguments. So the advantage of doing it this way is if the parent class definition changes, that I won't have to update my child class to add new arguments, because it'll accept whatever arguments the end user passes in and then pass them to the parent class. Now, what else do I do that's unique? Right to here, right to the super call, there would be nothing that would be, there would be no point in me having the init method in the child class. It would only be doing the exact same thing as if we had just called init on the parent class directly. But you can see the line below that I actually do something else. I actually specify an attribute that's unique to this class. In particular, I specify this self.platform equals CiscoIOSXE. So I've created a unique attribute here. So we do all the things that we normally do. We do the init, we call our parent class and do everything that init does in the parent class, and then we set up something that's unique here. In this particular case, we assign this platform attribute. So super is a way that you can invoke the method on your parent class so that you can do whatever set of things are done in that parent class's init method in this case. Okay, now if we look at our parent class, here's our parent class. We can see we inherit from nothing, and I put in parentheses object. We can see all our methods, and for placeholder purposes, I just put those as being passed right now, just to give you a diagram of what those methods look like. And in this case, I actually made a new method like say hello that could be unique by the parent class. So the new thing here is really this super call, this invocation of super. And this is really something, you could do this in Python 2, but this is really something that's Python 3, at least in this form. Python 2 had slightly different syntax for this, and the form of how to invoke super has gotten easier in Python 3. There was a way in Python 2.7 that you could use the new form, but you had to import something special to actually make this new syntax work. So the new part here is this invocation of super, where you're basically calling this init method on your parent class.